Hello and welcome to number 7.1. Number 1. So this is section 7.1. 7.1, number 1. Now, in this situation, you are giving an airplane ride. There's a visual aid on Google Classroom to your pet. Trying to find a darker marker. Here we go. So, here I am. That is me. I am holding on to my chicken. There is my chicken. It is being spun around as fast as it can. There's little tail feathers. So we're spinning around a chicken. And everybody's happy, right? Now, we go around and around and around. My arm has a radius of 100 centimeters, which is 1.00 meters. My chicken's mass is, as always, 3.2 kilograms. And the velocity is 3 meters per second, which is a good velocity for speeding chickens. You're not going to hurt them at 3 meters per second. In fact, you could run faster than the chicken. In fact, the chicken could run faster than 3.2 meters per second. So let's do some math here. Now, if you recall, force, centripetal force, is equal to your mass times the tangential velocity squared over the radius of your circle. So, the centripetal force is equal to the mass of my chicken. Now, a lot of people are like, is it my mass or the chicken's mass? Well, the chicken is the one that's being pulled around. So it is your chicken's mass, or whatever your pet is. 3.2 times 3 meters per second squared all over my radius, which for me is a nice little 1.0. So 3.2 times 3 squared is 9 over 1.0. And I end up with 28.8 over 1, which is 28.8 newtons. All forces are newtons. Now, if this seems like a lot or a little, just think about the fact that under normal gravity, the force of gravity on my chicken is equal to 3.2 times 9.8, which gives you a little over 30 newtons. So this isn't a very strong force. This chicken is not being hurt. So there you go. I have an illustration up on Google Classroom to help you understand the concept of spinning chickens. Now, let's think about what you're probably going to get. Now, my arms are very long. That makes this number bigger. If your arms are shorter, your force is going to be greater because you're going to be making a tighter turn. But your pet probably is not a chicken. If your pet is anything more than about 4, it's going to result in more force. Now, what's probably going to be a bigger factor? The mass of your pet or the radius of your arms? Well, I don't think anybody has arms that are half as short as mine. But I'll bet you most of you have pets that are twice as big as mine. So if your pet is more than twice as big as mine, that's going to be a much bigger factor in this than the length of your arms. So yeah, your arms are a little shorter than mine. That's going to be a small difference. If your pet's a lot bigger than mine, that's going to be a much bigger difference. If your pet is bigger than a chicken, that's going to be a bigger factor, and you're probably going to be needing a lot more force to keep that pet going around and around for you. So just something to think about. Expect an answer. Most of you will expect an answer that is bigger than mine when you're done. But I got 28.8 newtons, not as much as the weight of the chicken, but enough to have some fun with. All right?